session. I'm delighted to welcome Pradeep who is Enterprise Solutions Architect of CNA. Pradeep is going to talk about a subject that's of great interest to me because we did some research at QA Vector Research on this subject last year, and we found that whilst a lot of people on the business side thought that it was almost a necessity to move everything to the cloud, the challenge of moving to the cloud is much more complex than that. And often it was a business rather than an analysis-driven decision. What we're going to hear about today from Pradeep are the particular challenges of and the role of continuous testing as you migrate applications to the cloud. So with that said, Pradeep, welcome, and the floor is yours.
Thank you, Justin. Thank you very much. Hello, everybody. Good morning. Let me share my screen and we'll discuss more on moving to the cloud. What is the role of continuous testing? Just to let you know, moving to cloud is a vague subject and it involves a lot of other verticals as well, security or performance or cost or everything. So today we are going to discuss only the role of continuous testing while you are moving your application to cloud. To give a little bit information before we, the way how I put the presentation is, if you have an application that is a monolith application that has been there in your system for, let's say 10 years or 20 years, and now you decided to move this application to cloud, what are the different testing strategies, or what is the role of testing in all these moving applications to cloud? What are the benefits I'm getting in the new methodology of moving to the cloud, and what is the automation play role in this entire journey? So for our discussion, let's take an example of policy quoting application. I have an application which is a policy generation application. To give you a brief on this application, the user will log into the website, fill the data. Once he fill the data, he can able to the backend system does the validate data, and that validate data functionality in turn uses several modules like validate address, validate customer, and it calls an external system called calculate risk. Once you get that validation done, then you will send that screen to the policy premium, provide the premium. To provide the premium, you call rate take quote internal application module, and that gives you the premium. Once you get the premium, the user will look into the premium and say, hey, I want to take the policy. Once the user decides to take the policy, we issue the quote and generate documents related to that policy. So this is a very simple application. For the sake of our discussions, I made it much simpler. It is much more complex than this. So let's see, in a traditional monolith application, if at all we have built this application, this is how it is gonna be. We have all those modules built in one application. Remember the days of monolith application? It's as if I'm saying a long back, probably at least 2 years back, everybody uses monolith application, most of the companies. We built new modules within the same code base. So over a period of time, a lot of functionalities and technologies get overloaded into that application. A simple bug fix or simple change in that application leads to the application downtime. We have to plan for 15 minutes downtime or 1 hour downtime to make the application bring it back. And even if single line of code change, or since it is built over a period of time, it is very difficult for a QA person or even a developer who is currently made the change to identify what am I impacting? What are the systems I'm getting impacted? Let's say if I change any line of code in validate address, will it impact rate code? Could be or could not be, unless you as a developer go to each and every module and decide, see the code for yourself, you will not know. So that tend to happen a lot in monolith applications. And if you see the cycle of the QA, where the QA plays a role in our traditional application is, in SDLC lifecycle, you have code, build, test, deploy, and monitoring, right? So the QA only plays in the role of testing. They do not have access to coding phase, building phase. They have only at the time of testing phase. So in the world of monolith applications, QA play a tremendous role. Like unless the QA certifies that this build is good to go to production, we will not take them to the production, right? So these are the 6 challenges I could able to identify. I'm pretty sure there will be more. I would like to hear from you if at all you have much bigger challenges than this in our traditional method of building the application, the role of QA. Incomplete test coverage. We expect even if I make a small line of change in validate address, I expect QA to do end-to-end testing and they have to certify it. If something fails, it's not, as a developer, it's not developer responsibility, it is QA responsibility. We tend to say that it's all QA who tested and certified. But how much we can test when there is no automated test scripts available during those days, or even if we have, it's not complete, right? There is a chance that you might have incomplete test coverage. The QA might not complete all the scenarios. And there are multiple teams involved. So the system I brought up, you need to communicate with, calculate risk system, the external vendors as well, to ensure that their application is up and running, and ensure that we have to inform them, hey, I'm doing this testing, ensure that you are not making any code change and all, right? And the next challenge is it's a requirements. So over a period of time, you keep adding lots and lots of requirements. So what happens is after 10 years or so, your requirements documents are scattered across several places. The only person who knows the requirement might not be with the company anymore, right? And testing time, since it is a monolith application, even if you make a small change in validate address, you are forced to test the other modules which has no impact as well. That means you are spending a lot of time in testing the entire application. And then you have to manage the data as well. For you to test the application, you cannot mark the data in those modules because all are combined together and there is only one database or one source of system of truth available for you to ensure that data is accurate for you to do a simple test as well. If any data got changed because of other reasons, then your test is on halt. You cannot do the testing. The 6th one is missing dependencies. So we talk about upstream systems and downstream systems, right? How do I know if I make this change, these are the different systems that gets impacted? Do they inform? Are they informed? Did they do their testing? All those things we need to coordinate. If a new tester comes on board, it is very possible that he might miss to test the dependent systems as well. So again, as I mentioned, this particular session is more on continuous testing. There are ways that you can move your applications to cloud. So in our scenario, I try to break down our modules into microservices. The advantages of coming up with microservices is every functionality is built on its own application. Read the code, validate data and validate address, validate customer is all its own application, and it all exposed as a REST API. So the advantage of this one, every code base is separated and the requirements and functionality are isolated to that particular application. Let's take example of validate address. If I build an application with validate address, how long will I ever change validate address after 5 years or 10 years? Might not. So there is one component I have, once I build the automation around this component, I have confidence that I don't need to touch this validate address. Whereas issue the code or rate the policy, I want to make changes every week or every 2 weeks because there are so many rules involved. So now I can have a team dedicated to that particular rate the code to ensure that we are keep updating the test cases around it. And we can do a lot of performance testing, security testing around those modules to ensure that we are not impacting other systems as well. Irrespective of that, we are changing code base for the entire application. Even though we decouple the entire, all the modules, we are changing the code. So it is the QA responsibility to ensure what happens to the end user if there is a data change in validate address or validate customer or calculate risk. So we have to come up with different approaches on how do we address all those issues. The advantages of, again, this division of these microservices and moving to cloud is you get to cover the entire test coverage. For each and every module, you address the test coverage from each and every module, and then you tackle the overall end-to-end test by mocking a lot of services. So dependency management is very easy because you're talking in terms of REST APIs, so you know what exact service you're calling and for what. So I took an example of continuous testing. The definition of continuous testing is the process of executing automated tests as part of software delivery pipeline to obtain immediate feedback. That's the keyword, immediate feedback on the business risk associated with software release candidate. So this definition I got from Wikipedia. So now if you see the role of tester, it is from beginning till end, from the time of code, build, test, deploy, and monitoring. All these 5 phases, there is a role involved for testing. The QA is not the same person who does the testing in the monolith application world. Every phase you have a different person who call themselves as QA to ensure that that phase is successfully built so that you are going to the next phase. The test case in that particular phase is good so that you are moving to the next phase. I'm going to discuss in detail on how each phase is addressed and what is the role of QA in each phase. What are the different types of tests involved in each phase and how we are going to address. So just to give you a very brief on exactly where we are going, in the coding phase, the developer tend to write the code. The moment you write the code, you write a lot of, you need to, before you commit your changes, you need to ensure that you run your tests locally and commit the code. Then during the time of build, you have your automation script available so that the tests are run on CI/CD pipeline to ensure that, okay, this build is certified, okay, all the JUnit test cases and mock test cases are done. Now let's deploy it. Let's test the end-to-end test cases as well. Once you do the end-to-end test cases, you deploy the application and then you do the, again, in the phase of test, you do a lot of mocking the data. You do not want to test on directly connecting to the end service. For example, in the validate, in the previous slide, if I want to test the entire application, I have 3 or 4 different scenarios. What if validate address gives me a positive scenario? What if validate address gives me a negative scenario? Right? What if application, the service itself is down? I do not want the validate address application to create a data for me to do all those tests. I will mock those tests and do an end-to-end test in testing phase. And once I deploy it, I need to ensure my basic test cases are working. The real test cases that 90% of the time the users, what are the different users go through the scenarios, I would like to ensure that those test cases are successfully running. And monitoring is another key area where the QA plays a role. They want to ensure that this application is still running in production without any issues. If there are any issues, I need to know what are those issues and how am I going to cover those issues in my previous phase. I hope you could able to see the continuous testing pipeline clearly. I'll explain in detail on this pipeline. Let's say the developers, right? As I mentioned, the first phase is developers. Before we need to establish a process in place ensuring that before you commit your changes, do your JUnit test locally. You need to provide a script to them and ask them, hey, you want to commit your changes, run the script and let the script take care of committing the changes to repository. And that script can have a JUnit execution capability. So once that phase is done, the code is present in your SCM, and then you go to the automation server where you do the build. In the build, whatever test, this is definitely required. You might ask, okay, developers is already doing the test. Why should I do it on the automation server? So there are n number of developers. Not every developer does follow the process. Every phase is kind of a check to ensure that the previous phase has not failed in following the process. So in automation server, you can see the unit test where you run all the unit tests at one time and ensure that the merging of the code is not breaking up anything, or there might be some use cases that a developer might have the confidence saying that, okay, I don't need to run the test. I will push it manually. I know the way to push it manually. I have very confidence. That's the automation server will catch such scenarios. And as I mentioned, you need to ensure you mark the services and then test to ensure that the entire code base is not broken. And then at the same time, you can push this jar to a security scanning and vulnerability scanning, and also you can do code quality testing as well at the same time. At this phase, it's kind of you are sending this jar to different people, asking them to validate if everything is good or not. So you get the data and everything is good or not. If something that needs to be informed to the team, you do inform immediately to the team, either using Slack or Teams or even emails, right? You can inform that tests are failed, you go and check what's happening. So once you have this automation script is completed, then you go to the container creation service. Again, we are in the journey of cloud. Cloud, everything is container. You get one container and then put your jar in that container and then run the container, right? So there are vulnerabilities present in those containers as well. You need to ensure the container we are using is secure. So there is a security vulnerability scanning that needs to be done, and the QA does play a role in that scanning to ensure that, okay, this container, whatever we are moving to production, is secure enough that there are no vulnerabilities present for that container, not the code. Once you are familiar, once you are confident that I have the jar which has all the functionalities tested, and then I have security scans completed, now I will do the end-to-end testing. When I say end-to-end testing, again, you can mock the data or you can do a complete end-to-end testing as well. So the first test I would say is integration testing. I would ensure that my 90% of the use cases are working perfectly. And then I will go to I will ensure that if let's say I make changes to validate address. I don't know what are the different other systems that got impacted because of this change. Now, because this is a web services and we all know what are the different services are being used by what services, we can trigger the dependency services like upstream services or downstream services to ensure that this change is not breaking the upstream and downstream services. Once you pass that phase, then you want to do the performance testing to know that, okay, this particular code release is not impacting the previous performance that we already have. Or are we specifically addressing any performance test numbers? We need to address only those numbers to ensure that we are meeting those performance numbers. Again, you can do all the PIM testing and everything, end-to-end security testing to ensure that you are not introducing new vulnerabilities to the code. Once you are confident with this environment, you move the code to production. Again, in production, there is a different level of testing can be done. Once you move to production, you can enable A/B testing to see. Again, this is all somebody might say this is a behavioral testing and all. To know the business, for business to know how my application will be responding once I move to production. I would say even for QA plays a role to ensure once you move this particular code to production, the blue-green deployment will enable the QA to access the production instance much earlier than the production enabled time to ensure that all the end-to-end the URLs are working correctly and the changes that we moved are still intact so that it's not breaking. That's kind of confidence the QA team will get, or the entire application team will get, to enable the code for a general public, right? So that will definitely give me that confidence. And then verify the results. On top of it, enable full production. If there are any known issues, there are reasons that there could be some known issues that we don't need to stop moving to production, right? You can do that as well. Once you have that confidence, the another role that QA has to play is monitoring. This is a passive testing. You need to ensure the code that moved to production is not generating new issues. We need to ensure that there are not every customer reports an issue. That is key for all the products. Out of 100 bugs, there might be 1 or 2 people who are interested to put the information and say, hey, there is a bug in here, please fix the bug. We need to be attentive, and we need to take those stats into place and say, okay, how can I identify the issue before even customer reports to me? You need to monitor the logs or check if there are any errors going on in the production. There are different applications in place where you can check if there is any UI based errors as well. You can do that. And there should be a production support team which involves QA as well to monitor what are the different issues that are there, and should I log the issue for the next subsequent releases, or should I, is that a issue that is not stopping the user to move forward? So based on that, I can prioritize the work, right? So you can definitely do all that stuff. So if you see this CI/CD pipeline, QA plays in every phase of the pipeline. QA plays a role. In earlier, the QA has to wait for the developer to say, okay, I'm ready for my code is done, please go ahead and test it. Versus QA saying, my tests are ready. You deploy your code, and I will check if your code is good enough for my test. This is a significant change between the monolith application and the continuous and cloud-based applications. There is a continuous testing involved in this area. And let's compare the testing pyramids and confidence level. You might ask, there might be applications which are using automation even in the traditional place, right? Yes, it is possible that you might have automation scripts available. What is the possibility? How much amount of manual testing involved, and how much amount of automated testing is involved? That is the left side of traditional pyramid I mentioned. You might have automated testing, but is it doing all the scenario testing? 100% of test coverage, that is 100% of test scenarios have been covered in automation. In most of the cases, in several articles and several reports does say that there are a lot of manual testing involved in traditional methodology. And you really have a good developers if you have unit testing available. But once you move the application to production, what is the confidence level? Why does developers and QA has to keep looking the day of the deployment? We tend to look into the production and see, hey, is there any issues available? The confidence level is 50-50. Unless the customers do not report for 1 week, you'll be like, okay, hey, yeah, I'm happy that there are no production issues. We have to wait at least a month for sometimes to ensure that there are no production issues. Versus you go to the automation testing or continuous testing, you are forcing the developers to do unit testing to start with, and then your automated scripts are playing a huge role. You ensure that you have automated script for each and every component, every interaction, every functionality. And there might be a little bit of manual testing involved. I'm not ignoring the manual testing overall. There might be a manual testing involved. What is the confidence level you get in this level of automation testing? Is 90% is the confidence level you will get, because everything is automated. You're not breaking the existing functionality. The new functionality is, the new scripts are written for the new functionality. So this is the role of continuous testing in moving up your application to cloud. With this, I would leave for any questions.
Well, thank you very much, Pradeep. That was very interesting. Early on in the presentation, you talked about the challenges of breaking up monolithic applications into microservices. And then you also talked about the challenge of ensuring there are no gaps in test coverage.
Mhm.
Presumably there's a specific approach that you need to take as you break up a monolith to make sure that the interconnects don't get missed, the way that you code doesn't immediately create gaps as you break up the monolith. So how do you address that challenge?
So I'm not strong person to tell that go to monolith, go to microservices. So I'm more of between monolith and microservices. Consider a macroservice that addresses your monolith application functionality and combine your functionality as one macro service and then deploy to production. That way, you're capturing your application's functionality versus the component functionality. You have the confidence level at the same. You can build your confidence level much better if you design your application in such a way. Don't try to break your entire application into microservices. It is very hard to maintain the moment you have hundreds of microservices. It's really hard to maintain your microservices. Did I answer your question?
Well, kind of, because I think if I've understood you correctly, you'd perhaps be taking more of a business function approach. So if you take a business function approach, that's where you get to mini and macro services,
Yes.
rather than a computer function approach, which is where you get to microservices.
Yes.
But so it partly answers my question because you've got coherent pieces, but that still has the potential to leave gaps, particularly on the coverage of the handoff between one service and the next service, a handoff that didn't exist in the previous world when it was simply a monolith that delivered.
Yes, that is definitely a challenge in current world. It is definitely a challenge. But as you separate the functionality, there is a team that is going to take care of that particular functionality. If I say, okay, do write test for this entire monolith application versus start decoding the code and write test for a microservice as a microservice, there's a lot of difference. Now there is a one particular specialty team who works on this macroservice or microservice has to focus only on that particular functionality, which gives me more confidence in writing the test and ensuring that my existing test is covering the remaining lines of code or scenarios or not. Then the focus of the QA will be towards that particular functionality. So there is a gap, there will be gap for sure. You cannot have 100% moving all the tests from monolith to microservice or macroservice. So that is a transformation definitely you need to consider while you are migrating your application.
So Larry Britton has made a contribution suggesting that service contract testing can gather cross microservice test scenarios and then automate them as a collection. Is that something you've explored?
Yes, API first approach is one thing that we did explore that option. That involves all the integration partners to agree on that particular contract. Now you are depending on the third party to define, or one person who owns that contract. So yes, it is definitely a right approach, but there are more new people and new process in place, and it does play really good if you have an API exposed services. Definitely, that is one approach you definitely have to consider.
We've got very few seconds left, so just in a very few words, can you throw some light on any of the tool sets that you've used for testing or automation across the process?
So we are using several tests, several tools. I cannot give you one tool per se. Right now, we are in the transformation of our entire organization towards automation of QA. I do not have liberty to disclose exact tool that we are using, but we are using a lot of new open source tools and also vendors. We are right now evaluating the vendors as well.
Okay, I must say that we've sadly run out of time, as fascinating as this is. Thank you.